So the first speaker will be Mariia Kozlova, and this is our joint paper on satisfaction and extremity in the context of new formulations of multiple criteria decision-making problems.
As Jan said, it's our joint work, and there is something in the abstract in the proceedings. It's a little bit of extension from our original idea, but here I want to talk about the original idea so you know everything from the beginning. And what we are doing, we are proposing a new framework for multiple criteria decision making, the baseline approach. But let's start again from the very, very definition. What is multiple criteria decision making? We have a decision maker. And further in the presentation, I would refer to us, we as a decision maker, okay, just for simplicity. It's easier to talk like that. So, and then we have multiple alternatives that are varied by different criteria. Here we have size, the shape, the color, maybe something else. And the whole idea is that we are able to somehow compare these alternatives and evaluate them, and these criteria would be in different units or in different scales, so we somehow can evaluate them and choose the best one we want, or order them. So, and there are multiple methods for that, multiple methods for normalization, for aggregation, for how to assign weights. But the whole idea is always pretty much the same. One decision maker and multiple alternatives. And pretty much every method suggests that if we have two absolutely identical alternatives, then they are valued the same. Their value is the same. It's logical, right? And then, hey, who has a car? I have a car? Who else? Come on. Who have a car? Okay, many of us. Now, would you be willing to exchange your car for exactly the same car, same color, same brand, same everything inside is the same power, same age is the same, and mileage is the same? Would you be interested in that? No. Why would you? At least the mileage should be younger at least, right? So you become interested. So this is what we are doing. We are redesigning the problem formulation for multiple criteria decision making. It's not just the set of available alternatives, it's the one specific alternative also that is the baseline. Alternative that occupies the current solution, the car that we already have, or the absence of the car. That is also some kind of a situation with criteria we can evaluate in terms of transportation to work, on transportation in general in our life. When we formulate the problem in this new way, and when we specifically adjust the weights, I mean the algorithm, when we introduce an algorithm that is somehow related to the baseline, to our own alternatives now, we appear to have a bunch of behavioral effects out of that. One of them is that the same alternatives are not equal. So we wouldn't be willing to exchange our car for the same old car. There would be a positive cost of switching. There should be something better about the car, so it would attract us. And another thing is that if we are happy with what we have, we are tending to be risk-averse. We are not so much attracted to other alternatives anymore, even if there is something that is objectively better. The circle here is bigger, and the bigger the better, but we are not attracted to that anymore. So there is not just positive cost of switching, it can exceed something, so we wouldn't go even for a slightly better car. So let's say if the car you're comparing your own with something else is, let's say, I don't know, half a year younger, you are not interested. It's objectively better, but you are still not interested in that. Another thing is if we are not happy with what we have, then we are becoming more risk-seeking, and then we might be interested in something that is even objectively worse. So how does this go? There could be, for example, something in mind like, okay, maybe something that I have is already certain and I know everything about that. But alternatives out there, they are somehow associated with some other uncertainty, and maybe there are some criteria that I don't know about, and maybe there is something at the end better about that. So our method shows also that. Another interesting phenomenon that we can find with our framework is constant switching effect. So practically, if we have only two alternatives, and then we evaluate our own, we are unhappy, we are switching, then we do evaluation again, we are again unhappy, and we are again switching, and again, and again, and again. Yeah, but think about yourself, like you're thinking about leaving academia for industry, and you just came from industry to academia. So that is actually a good example for people who switch between careers. There could be something like that observable in human relations psychology, when you're looking for very opposite persons, one after another. So, okay, another thing is very interesting effect with a lot of implications for marketing and let's say business model development, whatever we are talking about. Introduction of something new, not necessarily fancy, not necessarily expensive, not necessarily innovation or breakthrough, but just something new that might be positively perceived, then that kind of alternative would become very, very interesting, immediately outstanding from all other sets of alternatives. And we can evaluate when it will be even better than the baseline, if somebody is happy. So to illustrate that new feature effect, there is a funny example of one hotel in Los Angeles. There is nothing special about that. The walls are awfully yellow. It's just average, good enough, good, but nothing special inside. But the price is comparable to the luxury hotels around. But at the same time, they are always busy, they are always booked up, and they always have very high rankings. Here in Google Maps, in Booking.com, what is special about them? It's a like mediocre hotel with super high price. So the special about them is the popsicle hotline. Near the pool, they have this red phone that anybody at any time can take and say, hey, I want an ice cream. And then next minute, a nice smiling lady comes with a silver plate and offers to you whatever ice cream you want for free. And in terms of hotel operations, it's nothing. But it's so much winning situation for the business. Like really. Okay, what do we have? We have a bunch of behavioral effects, very different, sometimes asymmetric. And the beauty of our suggestion is that they all come from a single framing of the problem and a single algorithm for weight formation. So what we offer is how to correct the weights practically in terms of perceiving the importance or desire to choose one or another thing. And this one is asymmetric, and here from where the effects come. So in the baseline, what we have, it's appreciating possessed effect. And in the alternatives, it's craving what is unavailable in the baseline. Let's have a look at it. So appreciating possessed, the better that our own evaluation of that criterion in the baseline, the higher the weight of that criterion for the baseline when we evaluate the baseline. So I like the color of my car. I'm happy with that. And so it's important for me to preserve it. And very simple linear formulation. So if we're using a scale, like say from 0 to 10, and I evaluate my color at being 7, then the weight would be 0.7, according to that. The higher, the better. And simultaneously, I value differently the alternatives. So the worse my evaluation in the baseline in what I have is, the higher the weight of that criterion in alternatives. So I'm unhappy with the color of my car. I'm stuck with that, I'm irritated by that, and it's very important for me to find something really cool when, in terms of color, when I'm looking for other options, right? Craving unavailable. And again, straightforward formulation, linear can be probably later be more sophisticated, but it's just maximum minus the evaluation of the baseline. So the higher the evaluation, the less the weight, and the other way around. Let's look at the numbers so it's a bit clearer. So here we have an example. Here's our baseline, 2 criterions. One is we evaluate as 7 and another is 4. And the weights for that would be 0.7 and 0.4. Again, the higher the better. If criteria is 7, it's 0.7. If 8, 0.8, etc. For the benefit type scale from 0 to 10. And then the overall evaluation is just weighted average. Here we are not using, for simplicity, other weights, like our importance, like of the color over the power of the car, for example, but just to see these correctional weights. How do they work? Now, for alternatives, the weights are different. Again, the higher the evaluation of the baseline, the lower the weight in the alternatives. So let's see. If we have exactly the same alternatives, 7 and 4 evaluations for 2 criteria, then if we just follow these procedures, the overall evaluation is much lower. So it's the same alternative, but it's not interested at all because we have the same. We don't need anything like that. Okay, another one, the opposite. Here, the evaluation is a little bit higher, but still we are not interested in something like that. Another one where evaluation of both criteria is higher than in our baseline, and still we are not interested. And only when the criteria number 2, where we have not enough satisfaction in our baseline, when it's super high, we become interested. With these simple numbers, here what we get. Okay, and important thing that the sum of weights is not equal to 1. It's an intentional, and it's actually what creates the effect. In here, in this situation, what we have practically that sum of weights for the baseline is higher than 1, than our average, so we kind of overvalue the baseline over the alternatives. Like that general atmosphere of the decision-making, general tendency, so we are risk-averse here. We prefer to keep the baseline over the alternatives. And only something really, really better might interest us. Let's check the opposite situation where our baseline is not valued that high. So then our weights, sum of weights for the baseline is lower than 1. Sum of weights for the alternatives is higher than 1. So we are risk-seeking. We're putting more value into the alternatives. And in this case, even the same alternative is more preferable. You never know, maybe something else about that is better than in what we have. You are willing to switch. Worse alternative, objectively worse alternative is better than the baseline. Well, even for that, you would be willing to switch. Now, this sum of weights is a little bit too straightforward, and it wouldn't work as good as it is now because, like, for example, if we have 3 criteria, then the sum would be already not, like, it would be not around 1 with that scale, but around 1.5. That is not convenient. So instead of that, we introduce saturation or satisfaction with the baseline, however you want to call it, and that is practically how, on average, the estimate of the baseline on all the criteria is higher than the possible average estimate. That's it. And then for this situation, it's minus 30%, so we are 30% below the mean with the baseline. Then if we change numbers, and it would be 4 and 6, or 5 and 5, or 6 and 4, or 7 and 3, it would be the average, so it's 0% satisfaction. We are indifferent. And here the sum of weights become 1, so we neither risk-averse nor risk-seeking. If the evaluation is higher than mean, then it's 30%, then it's 60. And what is interesting about that is that we are able to capture the gradient. It's not just whether you are risk-averse or risk-seeking or neutral. It's all the gradients inside. And here to remind you, it's all coming from how you value the baseline. From that comes the weights of the baseline, the weights of the alternatives, and all the evaluation, all those things are then kind of automatic. How you value the baseline, what is important in in this framework that we suggest. So, we, with a very simple algorithm, 2 rules working together, appreciating possessed in the baseline and craving unavailable in alternatives. And this very whole formulation, there is not just set of alternatives, but just one that is special, that we own, or that we have, or we have chosen before. This allows for multiple behavioral effects, and it's definitely useful in a range of applications. And okay, it's already pretty good, but to me, there are more benefits in that. So, first of all, maybe it's one of the first things where we are allowing for dynamic decision making. So you can model like you can change your mind, you can stick with something you like, or you can be constantly switching things, or if the pool of alternatives updates, you can reevaluate things and the decision could be different, or your own perception of the baseline could change. So it's totally different story. It's not just snapshot of one decision problem. It's an ongoing process. And of course, again, for different applications, this kind of pauses between the reevaluation would be different, but it's dynamic now. Another thing that I think has huge potential in here is that in most behavioral studies, it's just observation of the effect. It's a fact, it's an evidence. And okay, we have that. We are risk averse when we are dealing with gains, for example. And then there is multiple evidence because guys have conducted experiments, surveys, etc. And there is no underlying mechanism behind that. What we suggest here is something that explains things, something that you can model, something you can inbuild into intelligent systems that would help people make decisions that they want or would avoid biases in human decision making when some objective evaluation is needed. So I think it's cool. What we are going to do is that we want to conduct experiments because now we have this model in Excel with bunch of rules and bunch of evaluations and these effects. So we want to conduct experiments to validate that, yes, these effects indeed are there and it works as we think it works. Maybe doing some qualitative research case studies looking for more examples of these effects. Then there is definitely a link to Kahneman's theory, and we want to probably explore it more, maybe not. But what is in the prospect theory, if I summarize it very, very much, then practically, if we are in a domain of gains, then we are risk averse. Our baseline, we are satisfied with the baseline. It's plus, we have some certain money. And we are risk averse. We don't want to exchange that for something else, for some uncertain alternatives, a lottery ticket. If we are in the domain of losses, we are risk averse. We would go for a very risky opportunity just to avoid the certainty of losses. And so we say, we show exactly the same, but we also show the gradient, and we also can apply our situation not just to lottery tickets, not just to some, investments or monetary problems that can be expressed in monetary terms, but whatever, human relations, job, cars, marketing, business models, anything goes. Then, yeah, about human relations, there is an interesting link to attachment theory. Also how it's about human relations. It's about whether you are attracted and you are safe in the relationship, or whether you want to avoid it somehow, or you're unhappy, you're unconfident in your relationship. We have things there, and maybe if we find the right person willing to help us, then we will explore that opportunity further. Our action plan that we are doing right now, we need to publish that stuff first. So, and it's apparently difficult because it's just an Excel model, and we don't have any evidence, and we just got rejected from EJOR, European Journal of Operations Research, because we don't have any evidence. They said practically welcome back when you have done some experiments. But the editor and all 3 reviewers recognized the novelty and the potential of the idea. They liked it. Then with ANSI, we are designing now an experiment. So we are thinking what questions to ask people. So the answers will help us to validate this model. and to show that it works. And then we are also seeking funding, and it started from very ambitious idea to apply for a Finnish postdoc pitch competition, where the prize of the ultimate winner is 100,000 euros for research. So that would be interesting. It's our first idea for funding, because we realized it would be very interesting to convert these research directions from something that is just inspiration-based spare time to something really going on with some serious scientists involved. So this all is very new stuff. It might be sometimes controversial maybe to somebody or from different angles. It's all discussable. We will be super grateful for comments, critiques, ideas, anything, and we are very open to collaborations too.